Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. So our lesson today is on application of determinants. So objective. So first objective, you can find the inverse matrix using adjoin method, and second objective, solve the linear system using Grammus rule. Okay, so kita ada dua lah. So adjoin method and Grammus rule. Okay, so adjoin method. So what is adjoin method? So adjoin method is the method to find inverse matrix. Okay, so cara untuk cari inverse matrix. Okay, so how to find the inverse matrix? So first, let's say A is a matrix of n signs n by n. Okay, so A is a matrix of n by n, and Cij is the cofactor of Aij. Then cofactor a matrix C, this one is equal to this one, cofactor 1 1, cofactor 1 2, and so on, this one, and this one is called as matrix cofactor from matrix A. Okay, so ni adalah matrix cofactor untuk matrix A. Okay, so the transpose of this cofactor matrix is called the adjoint of A. Okay, so adjoint of A, we do a transpose of the cofactor matrix. Okay, so then the inverse of matrix A we search by using 1 over determinant of A multiplied by adjoint of A. Okay, so kita tengok how to find the cofactor matrix. Okay, so let's say A is a 3 by 3 matrix, this one. Okay, so but find the inverse of this matrix. Okay, so first, so to find the inverse, we need 1 over determinant of A and adjoint of A. Then to find the adjoint of A, we need to have cofactor of matrix A. Okay, so adjoint of A is the transpose of this cofactor. So first, find the cofactor. So find the cofactor for each element in this matrix A. So since we have 9 elements, so therefore here we will have 9 cofactor. Okay, so kita akan ada 9 cofactor. Okay, so cofactor for the first row and first column. Okay, so cofactor for these three. Okay, so to find the cofactor, okay, so recall back. So the cofactor of Ij, which is row I and column J, it is equal to -1 times with -1 power of I plus J. Okay, so I plus J times with the minor of Ij. Okay, so this one, cofactor of first row and first column, it is equal to -1 power of 2. So power of 2 because 1 plus 1, and then minor of 1 1. So minor of row 1 and column 1. So to find the minor of column row 1 and column 1, it is the determinant of the matrix, which is we close the first row, tutup row yang pertama, and column 1. Okay, so it is the determinant of matrix 6 3 -4 0. Okay, so M11 is the determinant of matrix 6 3 -4 0. Then calculate. So -1 power of 2 is +1, and then 6 times by 0, which is 0, minus by -4 times by 3, which is -12. So the answer is 12. And then cofactor 1 2. Okay, so cofactor 1 2, which is row 1 column 2, it is same, -1 power of 3 because 2 plus 1 is 3, and times with the minor of 1 2. So the minor of 1 2 is the determinant of matrix, which is we close the first row and column 1, column 2. Okay, so tutup first row dengan column 2. So it is the determinant of matrix 1 3 2 0. So calculate. -1 power of 3 is -1, and then 1 times by 0, which is 0, and then 2 times by 3, which is 6. Okay, so therefore -1 times -6, which is 6. And here also same for the cofactor of row 1 column 3. So it is -1 power of 4, so 1 plus 3, which is 4, and then minor of row 1 column 3. So we close row 1 and column 3. So So therefore it is the determinant of matrix 1, 6, 2, negative 4. So calculate, we have 1 times negative 4. Okay, so 1 times negative 4, which is negative 4, minus by 2 times 6, which is 12. So the answer is negative 12. Okay, so the same way we calculate the cofactor for row 2 column 1. Okay, so minus row 2 column 1, so close row 2 column 1. So here negative 1 power of 3 because 2 plus 1, which is 3. Okay, so calculate 2 times by 0, 0, negative 4 times by negative 1, so minus by positive 4. So the answer is 4. So the cofactor of row 2 column 2, so same, negative 1 power of 4, same way as previously. Okay, so sebelum-sebelumnya sama cara dia. So 2 plus 2, which is 4, then times by minor of row 2 column 2. So close the row 2 and column 2. Okay, so 3 times by 0, 0, and then 2 times by negative 1, which is negative 2. So 1, negative 1 power of 4 is 1, times by positive 2, which is the answer is 2. Okay, so here also same, C2, 3. Okay, so minor 2, 3, so close second row and third column. Okay, so negative 1 power of 5, so 5 because 2 plus 3. Okay, so negative 1 power of 5 is negative 1, so here 3 times negative 4, which is negative 12, minus by 2 times 2, which is 4. So the answer here is 12. And here C33, M33, M31, C31 and M31. So close row number 3 and column number 1, and then calculate. So power of 4 because 3 plus 1. So we have the answer here 12. 2 times 3, 6, and 6 times negative 1, negative 6. So minus by negative 6. And here also, so C32 is equal to negative 1 power of 5 because 3 plus 2 is 5, and then M32. So M32 we close third row and second column. So 3 by times 3, 9, minus by 1 times negative 1, which is negative 1. So the answer is negative 10. And here also same way. So negative 1 power of 6 because 3 plus by 3. And then M33, so close row number 3 and column number 3. So we have the answer is 6. And hence the cofactor of matrix CA is, okay, so cofactor of matrix A is 12. Okay, so bawa turun. So C11, 12, 6, negative 6. So 12, 6, negative 16. And then 4, 2, 16. So 4, 2, 16. And 12, negative 10, 16. 12, negative 10, 16. Okay, and then after we find the cofactor, okay, so after we have the cofactor, we can find the adjoint. So adjoint is the transpose of the cofactor. Okay, so before find the adjoint, we need determinant. Okay, so kita kena cari determinant lah. Okay, so the determinant you can calculate, it's up to you lah. So which row you want to use or which column you want to use. Okay, so for me I use column number, row number 3. Okay, so saya pilih row number 3 lah. So 2, negative 4, 0 ni, because we have 0 here. So therefore for 0 I didn't calculate lah. So I just calculate 2 and negative 4. So here A31, so A31 is 2 times with cofactor of 31. Okay, so 31, 31. Okay, so element in row 3 column 1 times with its cofactor. Okay, so elemen dalam baris ketiga kolom 1 ni darabkan dia punya cofactor. Elemen dia adalah 2. Okay, so elemen pada baris ketiga 1 ni adalah 2. Cofactor untuk 3, 1 adalah 12. So 2 darabkan dengan 12. And then element in row 3 column 2. So row 3 column 2 here is negative 4. And its cofactor is, this one cofactor is negative 10. And here this one element in column row 3 column 3. so which is 0, and its cofactor is 16. Since this one 0, so I didn't calculate lah. So ni teruslah buang lah, tak payahlah. So I have the determinant which is 64. Okay, so since I already have the cofactor and determinant, okay, so I can find the inverse of matrix A. Okay, so inverse of matrix A, it is equal to 1 over determinant of A times with adjoint of A, where the adjoint of A is transpose of the cofactor of A, so which is this one lah. Okay, okay, so this one, so 1 over 16 times by adjoint of A, and then I got the inverse of matrix A. Dah siap. Okay, so another example. So ni system of linear equation lah. So write above system in matrix form AX equal to B. Okay, so AX equal to B. So A coefficient matrix which is 2, 17 and 11. 2, 17, 11 for the first row. For the second row, here negative 1, 11 and negative 7. So negative 1, 11 and negative 7 for the second row. And then for the third row, we have here 0, 3 and negative 2. So 0, 3, 0, 3 and negative 2. And here is variable matrix which is x, y, z. And here is the matrix of B, which is this one, 1, negative 1 and 3. 1, negative 1 and 3. Okay, so this one is matrix A, this one matrix variable, and this one is matrix B. And then number 2, find the matrix cofactor of A. Okay, so we need to find the cofactor of matrix A, matrix cofactor. Okay, so we need to find the cofactor for each element in matrix A lah. So kita kena cari setiap cofactor dia. Okay, so again, okay, so step yang sama macam tadi. Okay, so C11 cofactor of row 1 column 1, so which is negative 1 power of 2 because 1 plus 1 is 2. Okay, so kuasa 2 sebab 1 tambah 1. And then the minor of 1, 1, so we close row number 1, and column number 1. And then find the determinant. 11 times negative 2, negative 22. 3 times negative 7, which is negative 21. Okay, so we have the answer here, C11, which is negative 1. Here also same, C12 cofactor of row 1 column 2. So negative 1 power of 3 because 1 plus 2. And then minor of 1, 2. So we close row number 1 and column number 2. So we search and then calculate the determinant, which is negative 1 times negative 2, here 2, and 0 times negative 7 is 0. So 2 minus 0. And then times negative 1, which is negative 2. And then C13 cofactor for first row third column. So negative 1 power of 4. So power of 4 because 1 plus 3. And then M13 close first row and third column. Okay, so then calculate the determinant. Negative 1 times 3, negative 3. 0 times 11 is 0. So we have the cofactor of 1, 3 is negative 3. Okay, so same step for another cofactor. Okay, so here C21. Okay, so M21 we close row number 2, column number 1, and then calculate. So we have 1. C22 is equal to negative 1 power of 4 because 2 plus 2 is 4. And then M22. So M22 we close row number 2, column number 2, and then calculate the determinant. So we have negative 4. And then C23 is a negative 1 times by a power of 5, which is 2 plus 3, 5. Then times with minor 2, 3. So M23, so close row number 2, column number 3. And then calculate the determinant. 2 times 3, 6. 0 times negative 7, 0. Okay, so negative 1 times 6 minus 0, negative 6. And here also same. Okay, so M31, close row number 3, column number 1. This one also same, close row number 3. Salah. Okay, so this one row number 3, column number 1, calculate determinant, times with negative 1 power 4, become -2, and this one M32, close row number 3 and column number 2, calculate determinant and times with -1 power of 5, so we have 3, and then M33, close row number 3, column number 3, calculate determinant, so we have, and then times with -1 power of 6, so we have 5, and then susun masuk dalam cofactor. Okay, so the matrix factor of matrix A is -1, -2, -3, so -1, -2, -3. For the second row, -1, -4, -6, -1, -4, -6, and for the third row is -2, 3, 5, -2, 3, and 5. Okay, next. Okay, so next, number 3. Find the determinant of A using cofactor expansion along the first column. Okay, so yang ni dia dah bagi tahu dia nak gunakan kolom yang pertama. Okay, so first column, so we have here 2, -1, 0. Okay, so 2, -1, 0. Okay, so tengok ni. Okay, so 2, -1, 0. Therefore, for the third one, this one, 0, this one, we didn't calculate lah. So, tak payah kira lah yang untuk 0 ni. Okay, so therefore, we have A11, A21. Okay, so which is 2 times its cofactor. So, for the row 1, column 1. So, row 1, column 1. So, we have this one. Cofactor is -1. Okay, so 2 times with -1. And then for the -1, this one, it is row number 2, column number 1. So row number 2, column number 1. Okay, so cofactor is -1, and element is -1. So -1 times -1, and this one 0 lah, because element in 3, 1, row 3, column 1, which is 0. Okay. So therefore we have the determinant of A, which is -1. Okay, so next, find the inverse of A using the adjoin method. Okay, so using adjoin method, so we have inverse of matrix A, which is equal to 1 over determinant of A times with adjoint of A. So 1 over determinant of A is -1. So 1 over -1. Okay, so adjoint of A is transpose of cofactor matrix A. So transpose this one, we have -1, -2, -3, and here row, second row become second column, -1, -4, -6, -1, -4, -6, and then third row become third column, -2, 3, 5, -2, 3, 5, and then multiply 1 divided by -1, so this one actually is become -1. So -1 times -1, 1. Here negative times -1, +1, and so on. So we have the answer, this one. Okay. So -1 ni darabkan pada setiap elemen ni lah. Okay, so next, and then solve the system using the inverse matrix or inversion method. Okay, so last time inverse method to solve the system, this one, the variable matrix X, this one. Okay, so to solve this one, so we need multiply this equation with inverse of A. So A inverse times matrix A times X is equal to A inverse times matrix B. So A inverse times A become identity times X is equal to A inverse times B. Okay, so identity matrix times with any matrix become this matrix lah. X equal to A inverse times by B. Okay, so therefore to find the value of the variable matrix, this one, which is X, Y, Z, so we need to multiply the inverse of A with the matrix B. So inverse of A we already calculate here. So 1, 1, 2, this one, and matrix B is 1, -1, 3. Okay, so calculate row times with column. Okay, so 1 times 1, 1 plus 1 times negative 1, so negative 1 plus 2 times by 3 is 6. And then second row times by column this one, so 2 times by 1 is 2 plus 4 times negative 1 is negative 4 plus negative 3 times 3 is negative 9. And then third row times this column, so 3 times 1 is 3 plus 6 times negative 1 is negative 6 plus negative 5 times 3 which is negative 15. Okay, so the answer is this one. Okay, next Grammus rule. Okay, so in Grammus rule, okay, so in theorem, okay, so let x equal to b be a linear system with n equation and n unknown. So macam tadi tu. Okay, so macam yang atas ni. Okay, so this one we call it as n equation. So 1, 2, 3, so 3 equation. Okay, so n equation, 3 equation here. And then n unknown. So unknown here we have 1, 2, 3 which is x, y, z. Okay, okay, so 3 equation and 3 unknown. Okay, so tu yang dimaksudkan dengan n equation and n unknowns. Okay, so if the determinant a is not equal to 0, then the unique solution to this system is xj is equal to determinant of aij divided by determinant of a. So kat sini xj kan, so xj ni kalau tengok soalan yang atas tadi tu dia mewakili x, y, z lah. Okay, so x1, this one x1, x2, x3 lah. So sebagai contoh this one, example this one x1, x2, x3. Kalau yang tadi contoh sebelum tu dia pakai x, y, z. Where di mana aj, so aj is the matrix obtained from matrix A by replacing the j column of A by the column vector or column matrix B. Okay, so macam tadi ni kita ada matrix A kan. Okay, so this one we have matrix A. So for the aj, for example A1, so we replace this B into the first column. Okay, and A2 we replace this B into the second column. First column ni biar yang ni lah, so kita gantikan yang ni dalam kolom kedua. A3, so we replace matrix B into column number 3. Okay, so tengok nanti example yang ni. Okay, so this one Grammus rule to solve the following system of equations. So we have this one. Okay, so we convert into matrix form. So we have matrix A, which is the coefficient matrix 1, 0, 2, 1, 0, 2, negative 3, 4, 6, negative 3, 4, 6, and negative 1, negative 2, 3, negative 1, negative 2, 3, and matrix B is 6, 38. Okay, so for the matrix A1, so A1 we replace this matrix B into first column. Okay, so tengok ni, ni dah ada dekat dalam kolom pertama, ganti sahaja. And for the matrix A2, we replace this matrix B into the second column. So yang first column ni sama dengan yang asal, third column sama dengan yang asal. And then A3, we replace this matrix B into third column. First column and second column same as the previous. Okay, so sama macam yang asal. Okay, to solve this using Grammus rule, so first tengok tadi kita kena ada determinant of Aj, so determinant of this each matrix, determinant of A1, A2 and A3, and then divide by determinant of A, and we need to have the determinant of A. Okay, so calculate the determinant of A. Okay, so I choose first row because here there is 0. So determinant of matrix A, this one is A11 times cofactor of 11 plus A12 times its cofactor plus A13 times its cofactor. So A11 which is 1, and then cofactor of 11 negative 1 power of 2 because 1 plus 1 is 2, and the minor of 1 1 plus. Okay, so for the second this one A12 is 0, so this one I remove, so saya tak kira lah yang tengah ni, so this one automatic become 0. Okay, so because second element is 0. And then for this one plus A13, so element in row 1 column 3 which is 2 times with negative 1 power of 4 because 1 plus 3 which is 4, and then M13. Okay, so saya turunkan bawah 1, negative 1 power of 2 is positive 1, positive 1 times 1 is 1 lah. So kalau 1 kat sini saya tak tulis lah. And then M11, so close row number 1 and column number 1. So determinant of matrix 4 6 negative 2 3 plus by 2 times negative 1 power of 4. So negative 1 power of 4 is positive 1 times by 2 is 2. And then minor of 1 3, so close row number 1 column number 3. So it is equal to 4 times by 3 is 12 minus by negative 2 times 6 negative 12 plus by 2 times with determinant of this one negative 3 times negative 2 6 minus by negative 4. So which is equal to 12 plus 12 which is 24 plus by 2 6 plus 4 which is 10. So the determinant of A, it is equal to 24 plus 20 which is 44. Okay, so next calculate the determinant of matrix A1. Okay, so matrix A1, so still I choose the first row lah. So because we have 0 here. Okay, so we have 6 times each cofactor which is negative 1 power of 2, so C11 1 plus 2 and minor 1 1. Okay, so and then plus. Okay, so second one, this one is 0 lah because here 0. And then plus by A13 times C13. So A13 is 2, element in row 1 column 3 which is 2. And then negative 1 power of 4 because 1 plus 3 times with minor 1 3. Then calculate, so 6 times negative 1 power of 2 is 6 times with minor 1 1. So close row number 1 column number 1 plus by 2 times negative 1 power of 4 which is 2, and then M13 close row number 1 column number 3. So the answer is 6 times with determinant of this one 4 times 3 12 minus by negative 2 times 6 negative 12 plus by 2 30 times by negative 2 negative 60, 8 times by 4 is 32. Okay, so it is equal to 6, 12 plus 12 is 24 plus by 2 negative 60 minus 32 is negative 92. So it is equal to 6 4 24 2 6 2 12 12 plus 2 144 minus by 4 2 times 9 is 1884. So the answer is negative 40. Okay. Okay, so negative 40. Okay, so next, determinant of matrix A2. So for the matrix A2, so this tadi ke atas. Okay, so ke atas jauh sangat. So ni sama lah, saya tulis kat bawah ni. So 162 equal to this one. Okay, so kita fokus kat sini lah. So A13 tu pun saya ada tulis kat bawah. So this one. Okay, okay, so A2. Okay, so for the A2, since there is no 0 element here, so I just choose the column number 1 lah. So saya pilih column number 1 lah sebab dia positif dan nombor dia kecil. Okay, so kalau tak nak pilih yang ni, pilih yang lain pun tak apa, tak ada masalah. Dah ke mana pula ni? Okay. Okay, so now, so determinant of A2, which is element in row 1 column 1 times each cofactor, element in row 1 column 2 times each cofactor, plus element in row 1 column 3 times each cofactor. So A11 is 1, row 1 column 1, 1, cofactor dia yang ni. Okay, and then A12, okay, so A1 in row 1 column 2 which is 6, this one 6, and then its cofactor this one, and then plus element in row number 1 column 3, so which is 2, and its cofactor is this one. 1 times negative 1 power of 2 is 1 positive, and then minor of 1 1, close row number 1 column number 1. Okay, and then here 1 times negative 1 power of 3 negative 6, then M12, so close row 1 column 2, then this one 2 times negative 1 power of 4, so 2, M13 close row number 1 column number 3. Okay, so therefore it is equal to 30 times 3 which is 90 minus by 8 times 6 which is 48, then minus by 6 negative 3 times 3 which is 9, negative 9, minus by negative 1 times 6 minus negative 6, plus 2, and for this one negative 3 times 8 which is negative 24, minus by negative 30. Okay, so the answer is equal to 72. Okay, so this one for the determinant of matrix A3. Okay, so I choose first column because here there is 0. Okay, so calculate. So we have, okay, so nanti calculate lah. So we have the determinant of A3 which is 152. Okay, so then in order to find x1, so x1 is determinant of matrix A1. Okay, so determinant of matrix A1, tengok tadi yang atas macam mana nak cari x1. Okay, so xj determinant of aj divided by determinant of A. So x1 determinant of A1, okay, so determinant A1 divided by determinant of A. So determinant of A1 which is negative 40 and determinant of A which is 44. So the answer is equal to negative 10 over 11. And then for x2 same, so determinant of A2 divided by determinant of A. So determinant of A2 which is 72 divided by determinant of A which is 44. So the answer is 18 over 11. And for the last one, x3, it is equal to determinant of A3 divided by determinant of A. So which is equal to 152 divided by 44. So which is equal to 38 over 11. Okay, siap dah. Okay, so next another example. Habis dah. Okay, so last example is one. Consider system of linear equation, this one. So write the above system in matrix form AX equal to B. Okay, so tulis lah. So first the matrix coefficient which is 133, and then 143, and then 134, and variable matrix which is X, Y, Z equal to 1, negative 2 and negative 1. And then find the determinant of A using cofactor expansion along the first column. Dia nak pakai first column lah. So first column we have 1, 1, 1. So we have 1 times by its cofactor. So first column, this one, 1. Okay, so this one actually first row, first column. So first row, first column which is negative 1 plus 2 lah. And M1, 1 plus by second one which is on the second row first column. So second row first column and times with its cofactor 2, 1, second row first column, so negative 1 power of 3 because 2 plus 1 times by m to 1, and then next this one. So third one on the third row and first column. So third row first column. So 1 times negative 1 power of 4, because 3 plus 1, which is 4. Okay, so it is equal to so 1 times negative 1, so it is 1 lah. Okay, so m11, so close first row and first column, and then 1 times negative 1 power of 3, which is negative 1 lah, so negative. M21, close second row and first column, and then plus 1 times negative 1 power of 4, which is positive 1 lah, so positive here. M31, so close third row first column, and then calculate the determinant. 4 times 4, 16, minus by 3 times 3, which is 9, and then here minus 3 times 4 is 12, minus 3 times 3 is 9, plus, okay, so plus 3 times 3, which is 9, minus 4 times 3, which is 12. Okay, so this one, the answer is berapa ni? So 16 minus by 9, which is 7, minus 12 minus by 9, which is 3, plus 9 minus 12, which is negative 3. So it is equal to 7 minus 3, 4 minus 3, which is 1. Hilang dah. So tadi jawapan dia 1. Okay, so 1. Okay, so this M11, M21, M31. Okay, so next number 3. Solve the system for x, y, z using Grammus rule. Okay, so using Grammus rule, first we need to find A1, A2 and A3. Okay, so A1, okay, so we substitute the matrix B, which is 1, negative 1, 1, negative 2, negative 1. Okay, so 1, negative 2, negative 1 in the first column. Okay, so kita menggantikan dalam first column this one matrix B. And then A2, we substitute the matrix B in the second column, and A3, we substitute matrix B on third column. And then find the cofactor of matrix A1. Okay, so matrix A1, so I use column 1 lah. So column 1, 1, negative 2, negative 1, 1, negative 2, negative 1, and then times its cofactor. Okay, so I have here 1 times negative 1 power of 2, so positive 1. M11, close row 1, column 1, and then negative 2 times negative 1 power of 3 become positive 2. Okay, and then M21, close row number 2, column number 1, and then negative 1 times negative 1 power of 4, so this one positive 1 times negative 1, negative 1. M31, so close row number 3, column number 1, then calculate. 4 times 4, 16, minus by 9, plus 2, 3 times 4 is 12, minus by 9, minus 3 times by 3 is 9, minus by 12. So here is 16 minus by 9 is 7, plus 12 minus by 9, which is 3 times 2 is 6, minus 9 minus 12, which is negative 3, negative 3 times negative positive 3. So the answer is 16. Okay, so next find the determinant of A2. Okay, so A2 also same. I use the first column. Okay, so saya gunakan kolom pertama. So nak pakai yang lain-lain pun boleh, row 1 ke row 2, row 3 pun boleh. So saya gunakan kolom pertama sebab dia satu-satu lah, senang. Okay, so 1, 1, 1, and then times by its cofactor. Okay, so cofactor 1, 1, meaning that row 1 column 1, cofactor 2, 1, row 2 column 1, cofactor 3, 1, row 3 column 1. Okay, so ni cofactor ni ikut pada elemen dia lah. So elemen yang ni adalah elemen 1, 1, iaitu row 1 column 1. So cofactor dia pun sama lah, cofactor row 1 column 1, dan yang lain pun sama. Okay, so calculate. So we have 1 times negative 1 power of 2, which is positive 1. 1 times negative 1 power of 3, which is negative. 1 times negative 1 power of 4, which is positive 1. And then M11. So close row number 1, column 1. And here close row number 2, column 1. And here close row number 3, column 1. Okay, so we have negative 2 times 4, negative 8. Minus negative 1 times 3, negative 3. And here minus 1 times 4 is 4. Minus negative 1 times 3, negative 3. Plus 1 times 3 is 3. Minus negative 2 times by 3 is negative 6. So it is equal to negative 8 plus by 3, which is negative 5. Minus 4 plus by 3, which is 7. Plus 3 minus 6, so become plus, so 3 plus 6, which is 9. So which is equal to negative 5 minus 7, negative 12. So negative 12 plus 9, negative 3. Okay, so for this one, actually A3. Okay, so for the A3, so same, I use the first column. Okay, so element 1 times its cofactor. Element on column 1, which is 1 times its cofactor, and element in row 3 column 1, which is 1, and then times its cofactor. So 1 times negative 1 power of 2, positive 1. Positive 1 times negative 1 power of 3, negative 1, so negative. Positive 1 times negative 1 power of 4, which is positive. And M11, so close row 1 column 1. Then M21, row 2 column 1. And M31, row 3 column 1. Okay, so calculate the determinant. 4 times negative 1, negative 4. Minus 3 times negative 2, negative 6. And then minus 3 times negative 1, negative 3. Minus 3 times 1 is 3. Plus 3 times negative 2, negative 6. Minus 4 times 1 is 4. So calculate. So we have negative 4, negative plus 2. So minus negative 3 minus 3, negative 6. Then negative 6 minus 4 minus by 10. So the answer is 2, negative plus. So 2 plus 6, 8. 8 minus 10, which is negative 2. Okay. So therefore we calculate x. Okay, so first variable. So first variable we use A1 divided by determinant of A. Okay, so determinant of A1, which is 16, divided by determinant of A. Okay, so determinant of A just now is berapa determinant A? So determinant A is 1. So bahagikan dengan 1. So divide by 1. So the answer is 16. And then for Y, so determinant of A2 divided by determinant of A. So determinant of A2, which is negative 3, divided by 1. So the answer is negative 3. And then Z, third variable. So we use determinant of A3 divided by determinant of A. So which is equal to negative 2 divided by 1. So the answer is negative 2. Okay. Okay, so that's all for our lesson today. So see you later on next time. Thank you and Assalamualaikum.